So we're winding down. Hopefully everyone has gotten their last little bit of energy, ready to go. I can see you're all anxious to get out the door. A little bit more introduction. Back in antiquity, when the IETF was thinking about what kinds of, okay. I'll go ahead and talk while you're doing that. The IETF was thinking about how are we going to actually deal with this new thing, whatever it ends up being, we're going to evolve off of IPv4 onto. I mentioned I was at Livermore. I actually was over there as the associate manager for the Energy Sciences Network at the time. And my job up to that point had actually been evolving a collection of protocols onto IPv4. Right, so the Department of Energy ran a dozen different networks, all different protocols, and they were spending all this time and energy getting everything migrated to v4, and then we were standing and going, guys, we're going to move off of v4 onto something new. We don't know what yet, but we're moving on to this. So I was standing in the back of the room, and there was this transition working group BOF discussion going on, and all of these high-level developers proposing things for, this is how we're going to do translation or transition of some flavor, whatever it might be. And I was standing in the back of the room mumbling to myself, been there, done that, doesn't scale. Right? The guy standing next to me happened to be Scott Bradden, who was the area director at the time, said, fine, you're the chair, fix it. Right? So I ended up being the working group chair of the Transition Tools Working Group for quite a while. I bring that up because I want to talk about transition goals before we get into the technologies specifically. You've heard a lot about you should do dual stack, you should do tunneling. Why is that the goal? Well, fundamentally, the goal for transition needs to be decoupling all of these pieces so you don't have interdependencies. You don't have to say, oh, tomorrow we're going to do v6, and that means we have to do all of these services, all of the network, all of the end systems, all reconfigured simultaneously, right? That just sounds insane, and it is, right? So you want to decouple all of this as much as possible, right? If you start from that premise, then you start working your way back to, okay, well, given all of these options for how we might do a transition, what are the choices, and which things do we want to pick up first, right? So we want to start with why do we want to do this? That was the closing comments here in the previous talk, right? Why? What's the business case? You want to do things at a business pace, not a network needs pace. That was always the goal. Where are we? We're being forced into network-driven pace because the network and everything is delayed well beyond when it should have happened. But our goal has always been allow things to occur at the network needs pace. That means you should really start early. Well, start early is too late. If you have to be finished by 2014 and you are going to take at least 5 years to do this, you're too late already. Another goal, minimize complexity. Almost every conversation from somebody who's never looked at this before goes, oh, I'll just translate. I have v4, I'll just translate to v6. Well, at some level, yeah, you could think about doing that, but how do you know whether this has already been translated or not? How many times are you going to do translation? Are you going to go from 4 to 6 to 4 to 6 to 4 to 6 to 4? How many times? And can you tell when you should or shouldn't do translation? Right? You really want to minimize the complexity and make things easier to figure out. And finally, a really big goal was to avoid stagnation on a transition tool. Owen mentioned earlier, there's nothing more permanent than a temporary solution. Right? So fundamentally, we wanted to say, make sure whatever happens, you've got the path out of transition. And given that goal set, I said, the working group will do dual stack first. We can talk about all the other approaches later. But the one thing that I had, from experience in doing this for the Department of Energy, come across was you allow application by application movement independent of each other, and you allow the traffic to move to the new protocol and let the old one wither away. And that's how you simplify things. If you lock in a translator, you can never get rid of it, because one end will never go away. You've never forced the issue. So now back to the topic, tunnels, translators, and proxies. Well, I've got this set of goals. I'm going to talk about them in the order that I was asked to talk about them, which is tunnels, translators, and proxies. But in fact, the priority order is not that. The priority you should be thinking about it is tunnels. I've heard a lot of grousing about tunnels, right? Various presentations have said tunnels are things to be avoided. If you go to NANOG or RIPE, various meetings where operators gather, you'll hear lots and lots and lots of complaining about tunnels. And in fact, if you step back and think about it, the internet was built as a tunnel over the voice network. Tunnels are not bad things. It's how you manage the endpoints that matters, right? One of the conversations I was having yesterday, people are complaining about 6-to-4 as a specific tunnel technology, and we'll come back to this in a little while. But it's not the technology that's the problem. It's the fact that operators have chosen to allow a third party to operate one of the components of their offered service. And they complain it doesn't work right. Well, if a third party is operating your service, why should it work right? Right? If you expect it to work, you have to manage it. A tunnel is nothing more than an overlay. If you step back and look at it, IP is tunneling over Ethernet. IPv6 is tunneling over Ethernet. Step back far enough, the IPv4 internet is a nice, global, non-broadcast framed network. IPv6 will run across those frames just fine. Encapsulate IPv6 in IPv4 and you've got a nice, global, non-broadcast network. Treat it like any other NBMA technology, and guess what? Life gets really simple. But if you approach it from, oh, it's this encapsulation, I have to do deep packet inspection, and think about it from the bottom up, it gets really complex looking. But if you take the big picture and say, it's just a framing header, happens to look like a v4 packet, but it's a framing header. From the application perspective, dual stack is simpler because it is the way that they can choose whichever technology works correctly, and they can move at their own pace. Tunneling is virtually dual stack as far as the application is concerned. There are going to be MTU issues. But beyond that, as far as the application is concerned, they both are there, they both work. Right? So if you look at it, again, from the bigger picture perspective, you really want to go down the path of using tunnels whenever you can. You know, dual stack native first, but if you can't do that, manage some tunnels. Make life better. The applications will thank you for it. Path MTU discovery has to work, as we heard in the previous talk. A lot of people tend to block ICMP just because. One of the specific things we did was we took Path MTU discovery and gave it its own ICMP type in IPv6. In IPv4, it got inadvertently blocked because it was a subtype of something else that people wanted to block. So in IPv6, we said that will be a problem. We gave it its own type, so you don't have to block it, unless you do a blanket block of ICMP, which is going to create the same problem. You will find tunnel asymmetry to be an issue. While there's been lots of praise of Hurricane Electric, and I can't complain, you know, I use their services as well. Between Comcast and Hurricane Electric, there's a tunnel asymmetry that's going on. In the Seattle POP, in the Weston building, there's a 20 millisecond asymmetry between 4 routers. 20 milliseconds within the building. Why do I know this? Because NTP, for all my v6 peers, is off by 10 milliseconds. Right? And I've actually, because I saw that particular issue, I started tracing down why the NTP v6 peers were all off by 10 milliseconds. I found this tunnel asymmetry. but nobody can actually nail down why the tunnel is asymmetric. There are 4 machines sitting adjacent to each other, logically in the same building, but the path is 20 milliseconds skewed from each other in both directions. So something is wrong. You're going to end up with diagnostic issues related to that. I said I'd get back to the tunnel, issue earlier. Managed tunnels are things that you explicitly configured. This endpoint is going to talk to that endpoint. When you're doing an HE tunnel, that's exactly what you're doing. I'm doing a managed tunnel between this box and that box. Could be between routers, could be between endpoints, doesn't really matter. There are a bunch of automated tunnel technologies out there. And frequently you'll hear the complaints about the automated tunnels. It's not the automation, it's where the endpoint is. So you heard some questions and concerns about security in tunnels. Well, one of the first things that you should do as an enterprise, if you have not installed a ISOTAP 6-4 and or Teradata router inside your network, you should do that. Right? If you really are concerned about all of the devices automatically tunneling 6-4 outside through your firewall and not seeing it, guess what? If you install a 6-4 router inside your network, advertise that address inside your network as a host route, all those devices are going to find you. Right? They're going to come up and say, I'm trying to find the Anycast address for the 6-4 router. You say, fine, here it is. And they all tunnel directly to you. What does that do? Gives you a nice honeypot. Now you know exactly which hosts are configured to have 6-4 turned on automatically, so you can go find them. It keeps them from getting out, right? Because you've terminated the tunnel. It doesn't have to go anywhere. You just have to advertise, I'm the endpoint. All the V6 over V4 packets come to you. And you can choose to do with them what you will at that point. I say you should do ISOTAP as well. This is actually one of the places almost every enterprise should start. You don't know what applications could be running over your internal network until you turn on something like ISOTAP, and gives your support team some experience, right? It'll just work. Turn it on. If you're running OS 10, I see a few Macs out here, it doesn't have ISOTAP built in because Apple chose not to. Talk to me. I wrote a little script that will emulate ISOTAP on OS 10. Right? When I was at Cisco, that was exactly, I didn't catch the talk about the lab support, but one of the ways we got Cisco bootstrapped was have one of the labs with an ISOTAP router in it. So everybody could use ISOTAP to get to that router, except the OS 10 clients. So I sat down and wrote a little script to emulate ISOTAP on OS 10, and sure enough, everybody in Cisco that has a Mac is running that script, right? Because that's how they get out. It's where the control points are. So think about it from that perspective. A tunnel endpoint is a control point. Put it right outside your firewall, or right inside your firewall, or both, right? Drop it to V6, run it through the firewall, and then tunnel again if you need to. But it gives you places where you can force traffic to go to where you want it to go. Firewalls will often do one of two things. They'll completely ignore V6 tunneled, or they'll completely block it. Neither which is really desirable. You really want to have a way to drop the V6 traffic out of a tunnel, run it through a real firewall, and then figure it out on the other side. Translators. This is the last thing you should ever think of doing. Right? Paul Tuccia and I actually had this long, ongoing battle because he claims he's the inventor of IPv4 which, if you look at it from an RFC document perspective, yeah. But I actually presented it to a group in MIT in 1987 where the Department of Energy was thinking about deploying what looked a whole lot like that same thing. And I was told, no, it can't possibly work. It's going to break all the applications. FTP can't possibly work through a NAT. So I gave it up, right? It's a bad technology. I understand it very, very, very well. I wrote the Internet Architecture Board RFC on the implications of NAT in the network. And people kept saying, oh, you don't understand NAT. I said, I submitted the document through 2 layers of NAT. I know exactly what it does. One of the big things that people say today when they're saying, oh, the carriers can deploy NAT, they'll solve our problem. We understand exactly how NAT works. And I said, no, you don't. You understand how NAT works at the edge. Move that NAT into the core. It has a completely different characteristic. Yeah, what's going on in terms of mangling the header is exactly the same. But who has control? It's, again, all about control points. What's going on underneath really makes a big difference. It's not the bit pattern at the end of the wire, it's the who had control over what that bit pattern looked like. Becomes a security issue. A fundamental tenet of any security model is an audit trail. You put a translator in the middle of the network, where's your audit trail? Right? If your security people say, I absolutely have to have my NAT, ask them where the audit trail is. If they can't answer the question of the audit trail, then they have no security. If you're doing translators, all those translators will have to have application layer gateways built in all along the path. You synchronize your application deployment with your network deployment. That was explicitly one of the goals to avoid. Right? We don't want to have synchronized requirements. We want to be able to decouple things everywhere. So this is a place where you want to do this last if you have to go here. Payload length, we heard a little bit about that earlier. You know, in one direction you can get away with it, in the other direction fragmentation gets really ugly really fast and things will break. I said already, you know, daisy chaining is an issue. If you have lawful intercept requirements upon you or other accounting and internal documentation requirements, Sarbanes-Oxley, whatever that might be, if you have requirements that say you must account for this transaction occurrence, you will probably have to start monitoring every 5 tuple at points in time because you don't know what a device is. A device is the NAT, it's not the end device, it's the where's the nearest endpoint. It's, you know, one of the things I just realized as I'm looking at this, I left off geolocation, right? So if you are running a service and one of your services is trying to provide information local to the person who's asking the question, you know, take Google just down the street here, right? They offer to give you ads based on where you are or responses to your query based on local. You say, what's the nearest restaurant? They look at where you are and then give you the answer, right? They can't do that if the question came from a NAT that's 20 miles from where you are, right? If they parked a big NAT in Sacramento and you ask where's the nearest restaurant, you'll find out all about the restaurants in Sacramento and you're standing in San Jose. How does that work? Right? So if you think about offering a service and you're trying to do geolocation-based responses and the carriers are off here doing this V4 multi-layer NAT, how's your service going to work? And finally, we get to troubleshooting. So you've got this multi-layer NAT. Life is good. We understand how NAT works. Tell me your first level help desk can sort out the top drawing. Tell me. I want to see anybody's first level help desk that's sorted out the top drawing. What was spoken on what end at what point in time? Right? And I left off several of the NATs. If you've got edge NATs, they're not even on the drawing. Right? And if you've got other translations going on inside your network, there's no chance. Right? And that's just trying to document how bad the audit trail issue is. And then you look at the bottom part of the drawing. It's just dual stack. That could be tunnels. From the application perspective, it doesn't matter. It's speaking one protocol or the other. There's nobody in the middle messing with the packets. You don't have to worry about help desk sorting things out. They have to say, Does ping v4 work? Does ping v6 work? And whichever one of those answers, and then whatever your priority is set as to which one is preferred, you should be able to figure it out pretty quickly. But, you know, this is the world we're moving into, and I made it really nice because I only put 2 large-scale NATs, one on each end, right? That could be replicated as many times as there are carriers between the 2 endpoints. Because as the carriers get pushed harder and harder, they're going to be forced into more and more layers of NAT. We just had a recent RFC effort. I don't know exactly what state things are in, but the carriers have realized that they can't readily map whatever the customer address space is into non-existent space on their side because they don't have any new addresses. There have been carriers in the past that just randomly picked blocks that were not allocated, and then once they were allocated, their customers couldn't get to those networks, right? The NAT that's doing this translation has to have independent address spaces on either side of it, or it gets confused, right? And so if you have these overlapping spaces, you're going to have to do lots more mappings just to sort out and keep each address realm isolated from each other. Proxies is at the end of the list, but in fact I prefer proxies over translators. They're intermediaries and control points as well. They tend to be application aware, though not necessarily. A SOX proxy is not particularly application aware. Can get in the way of some applications, but it's more a matter of is the application SOX aware than is SOX aware of the application. They tend to need to know semantics about what's going on. And there are some instances of proxies that appear to interlock either side, but in reality they're independent TCP states. Right? So if you go fire up Windows Server, for example, you know, you can get it pretty much anywhere, but I know it's built into Windows Server because when I was at Microsoft, one of the things we did was put a proxy into that. Right? So it's in XP, Windows 2003, you know, and onward. Fire up NetShell, look for port proxy, and you will find there's a way inside the box to take anything on whichever protocol on a particular port and send it out the other protocol on the other port. Right? It's just built in. So I ran my web server on Windows 2003 as an IPv6 enabled server for years. Right? It's still running actually. You can get to it over v6. Microsoft doesn't support that. It shouldn't work, except for the fact that there's an internal v6 port proxy that takes the v6 question coming in and pumps it internally v4 to IIS. Right? So you can get there from here, and there are ways to do this. I also ran an SSH service that way. It comes in, v6 hits one of these port proxies and drops out the other side v4. Because the particular box I was going to didn't have v6 enabled SSH on it yet. So you have to think about what is the way you want to make this work. There was another comment in the previous talk about T-Mobile and how you can get v6 service out of these things. I happen to have a new v6 enabled T-Mobile phone, just got a couple weeks ago. v6 only APN. Life is good. They do their 6.4 proxy for web browsing and all that kind of stuff. I fired up VPNC, open source VPN client. It's not v6 aware. There's no v4 address on the interface. It just dies. Right? So if you're an enterprise and you have custom in-house apps that are v4 only, and somebody gets one of these new v6 only phones, you're screwed. There is no proxy. That's not going to fix your problem because it's trying to speak v4 on the box that has no v4. Right? There's nothing the carrier can do to fix that problem because it's outside the realm of where it's at. A proxy will help some things, but it's not going to help the problem of a v4 only app talking to a v6 only stack. Right? There were some proposals for bumping the stack long, long ago. Those were all basically tabled. It's still possible technically to do it, but it's not there unless you look at things like this port proxy in Windows being a bump in the stack that's saying, well, I think I know what you really meant, and send it up the other stack. If you're currently using v4 proxies as your demarcation point, a lot of enterprises will use a application proxy as the way to get in and out of the enterprise network. Then logically it makes sense to keep doing that v6. There's no reason to change the security model between the two protocols. We talk about end-to-end and we talk about all kinds of things, but there's nothing inherent in those discussions that makes you want to change your security model. You do need to go back and look and understand, why is the security model the way it is? And is it what we really want or need? If it's there because you believe that the port proxy is a castle and your problem is people clicking on links that are embedded in mail, it's not going to help, right? It's, that's Joe's discussion earlier. You have to think about, why is the model the way it is, and is it protecting the way we think? And if it's doing the job you want to have done, it's a perfectly valid tool. Keep using it. Oops, how do I back up here? I went 2 pages and I wanted 1. There we go. So, trade-offs. Deployment of any of these, or all of them, is really a local needs-based decision. Again, why are you doing what you're doing? One of the reasons that people would do tunneling, and that makes a lot of sense, is you've got a whole pile of equipment that can't do v6. It's budgeted for replacement next year. Don't screw around with a budget, just tunnel over it. Next year, after it gets replaced, it'll all just go away, right? Look at it from the how does this go away perspective, and make sure you're not building in infrastructure that can't go away. If you look at Windows Stack, I was the program manager for Windows XP and v6, and it will try Teredo, it will try 6.4, it will try native v6. The thing is, it will actually use them in priority in the reverse order from what I just said. If there's a native on the wire, it will use it, period, full stop. If that's not there, it will try 6.4. If that's not there, it will try Teredo. It keeps going up the stack till it finds a way through. On my board when I left was tunneling v6 over HTTP. Keep going up the stack until it just works, right? The point was to make the application developer comfortable that they could get the bits from end to end. Decouple things, allow the application to be deployed. When the network manager goes, but I need to control this, is fine, turn it on native. You have control. It'll stop doing all this other stuff. Yeah, it's all there, but it's going to prefer the most efficient path. Its internal prioritization is use that one because it's the best path, right? So it will go down and grab that. Now I do say that with the, it's one of those unfortunate things of having left. The Vista and Windows 7 implementation has a bug, and I've told them about it, where the isotap preference isn't right. So it will actually use isotap even when it has native, which is wrong. But fundamentally, the way it was designed and the way XP got implemented, it will work its way to the most efficient. You will probably end up using all of these in combination in various places in the network. They're not a one-point solution solves all problems, right? They are this is a tool that you use to solve a particular problem. You use it for that place, you go to use something else somewhere else. What your applications need will be your choice and determining factor, right? Again, having an application that needs IPv4 that's on a phone that only does IPv6 will drive you into a VPN client that works? I don't know. Right? I'm still working on that solution, trying to figure it out. Remember, security is the issue, and you need an audit trail. And translators inherently break the audit trail, especially if somebody else is running the translator. And how many of them are along the path, you can't tell. right? Unless you've got an end-to-end fundamental model where you can say, and I really, really, really want AH reinstated because now I can sign the header and verify that nobody has messed with the header along the path, right? That's one of the fundamental reasons that AH got created, so you can know this header has not been mucked with. The reason we've fought so hard about it is because if you turn on AH, you break all of this NAT infrastructure that everybody is so enamored with, right? At the end of the day, there is no one-size-fits-all solution. Everybody wants one. They keep coming to the IATF and say, you never gave us a solution. You gave us all these tools. In fact, they argued we should shut down the transition tools working group because we had too many tools. Right? And if you look at the IPv4 internet, there's no one-size-fits-all deployment model. I bet I could ask every one of you in the room and not get two answers that are the same in terms of how your network is deployed and why and what the security models are. Right? Yeah, you might be following a cookie cutter as a starting point, but it's a starting point. So there's not going to be a one-size-fits-all gets us from here to there because you're starting from different places. Even if there's a one-size-fits-all destination, which there won't be. So don't look for it. Look at the tool set, look at your environment, figure out what it is you needed. Multiple approaches will exist, but if you look at the goal is, I'm trying to get the applications deployed so that I can think about new things or making existing things work, right? It comes down to this keyboard bounces. It comes down to business continuity. You know, the question of why. What's your business going to do in 5 years? Are they going away within 5 years so you don't really care? That's one answer. If you expect to still be in business in 5 years, how are you going to run if all of the mail apps that are running on the new handsets are speaking v4 to a v6 only handset or to a v4 only mail server? Right? How does all that work? It's business continuity. And you can say, well, I'll keep using handsets that are v4. Well, that's going to go away real quick now. Right? Within the next 3 years, you know, you're going to find that a big chunk of the internet is v6 only connected. It'll be going through proxies and translators, and performance will suffer, and a lot of apps are not going to work right. Make sure that the tools you use are focused on decoupling. Simplify your life. Allow each group to move independently. If you force the mail group to move because you're moving their network because you couldn't get an address block big enough and you need to recapture those addresses to put somewhere else, right? You've now imposed business constraints on them. You've cost the company money, even though ostensibly you're saving it by moving the addresses somewhere else. You can hand wave all day, but you know, your goal is to decouple every dependency you can. It's already too late, but get started now. It's going to take you 5 years at least. You know, large organizations have a much harder time. Microsoft, we had v6 running internal to the network before I left. If you ask Microsoft IT today if they're done, they would say no. Right? That's 10 years, 12 years. Cisco IT, they've been gone there for a year and a half. They're just getting started. Right? They've been at it for 3 years. They're just getting started. Comcast has been officially telling the world for 5 years. They've been working very hard at it. They're not even close to finished. Right? This is a multi-year problem. If you think you need to be there in 2014, you're too late. But get started now. So with that, any questions? I knew I'd lull you all into sleep before you had to wake up to go home. Well, if there are any that come up, the address is on the slides. I do offer to answer any that come up, you know, so send me email. And hopefully you will be productive in your own deployments as you go home and take this to heart.